The third lesson in our quadratics unit is about the grouping technique. The grouping technique is very useful when the AM method is not available. For example, when your lowercase a, your quadratic term, is equal to something other than 1. Grouping technique can be very helpful. Learning target for this lesson is I can factor for the roots when a is not 1 using the grouping method. We can use the GCF and then the AM method. This is not technically grouping. This first example shows you that sometimes it looks like you won't be able to, but then you can use the AM method. We see 2x squared plus 12x plus 18. My first instinct is to say, oh, well, a is not 1. I don't know if I could use AM, but there's a GCF of 2. So y is equal to 2 parentheses x squared plus 6x plus 9. I now see that my a value is 1, so I can divide both sides by 2, set it equal to 0. X squared plus 6x plus 9 is my remainder. I skipped a step of writing there. Hopefully you all know what it is. Again, as I said, I divided both sides by 2. Now that I have this, I can use the AM method as we did in the previous lesson. What adds to 6 and multiplies to 9? Factor pairs of 9 are 1 times 9 and 3 times 3. The only factor pair here that would ever give me 6 is 3 and 3. So I'm going to say that 0 is equal to my factored form, x plus 3 times x plus 3. Now at this point, we, again, are reviewing our unit, so we should be able to identify that this is a perfect square trinomial here, and therefore we have the same number twice. I can use zero product property. 0 equals x plus 3, 0 equals x plus 3, so negative 3 is x in both cases. Based off of that, I find that my two roots are the same, and I'm done. I'm good. I can also see that my y-intercept, it is not going to be 9. It is going to be the 18 from the original quadratic. Very important that we know that. I could then do other calculations and find them, but let's move on to grouping. The similarities and differences between these two, just to point that out, is that when a is 2, we have a tall and skinny quadratic, and when we then factor out the 2, it's not as tall and not as skinny. These two graphs are the same scale. They go up to 6 on the y-axis in both. We see that one is definitely thinner and taller than the other one. Axes of symmetry are the same. We see that the axis of symmetry here is negative 3. Axis of symmetry here is negative 3. No surprises about either one. I did miss that pretty much entirely, but you get the idea. So when a is not equal to 1, am can be expanded. The product of a and c is our new m. So let's try grouping. Again, we know what this is. Our first step is to multiply 3 times negative 5 and get negative 15. Negative 15 factor pairs, 1 times 15, 3 times 5. And which one of those could add to negative 2? So again, we're using this guide on the side as our new value of our capital M, but the value of A is the same. It's going to be, or of capital A, is negative 2. Well, 3 and 5 could combine to give us that. So we're going to factor this out. We're actually going to not factor it out. We're going to split it apart. We're going to say 3x squared minus 5x plus 3x minus 5. Then we can split this down the middle. We could say, all right, well, on the left, I have a GCF of x, so y is equal to x parentheses 3x minus 5. This method only works if both sides have the same parentheses, so 3x minus 5 goes on this side, and what's the factor of this to give us the same thing? It would be positive 1. Now I have a new expression, and the GCF of that new expression is 3x minus 5. It appears on both sides. So 3x minus 5 is what I'm going to pull out. What's left over is x plus 1, and y is equal to this. Now I can use my zero product property. 0 is equal to 3x minus 5. 0 is equal to x plus 1. 3x minus 5 can be solved by adding 5 to both sides and then dividing by 3. So 5 over 3 is one of my roots, and I subtract 1 from the other side. Negative 1 is equal to x. That's my other root. So my two roots here are positive 5 over 3 and negative 1. Again, the grouping technique, I make this guide on the side, a times c. There it is. Axis of symmetry and vertex for this particular quadratic. This is the same one from the previous example. Axis of symmetry we can find in two ways. One way, x is equal to negative b over 2a. I know a is 3, b is negative 2. c is negative 5. I can substitute in negative 2 over 2 times positive 3. That would be positive 2 over 6, which is 1/3. That's my axis of symmetry. I could also find the average of the two roots. I have negative 1 and positive 1 and 2/3. If I were to say negative 1, use a different color actually, negative 1 plus 1 and 2/3, well, that would just be 2/3 because the 1 and the 1 cancel. And then from my my positive 2/3, I'm then going to divide that by 2 because it's the average of the two roots, and the average of, 2/3 divided by 2 is 1/3, which is the same thing I got here. So knowing the two roots, I could find the average. It will give me the same information. My axis of symmetry is going to run right down the middle, which is the 1/3. My vertex is going to be one step further. I substitute 1/3 into this particular equation. The work for that is pretty involved. I'm going to do it without narration, but you can pause, fast forward, whatever you think is most relevant to you. But y is equal to 3 times 1/3 squared minus 2 times 1/3 minus 5. I then have 1/3 squared, 3 times 1/9 minus 2/3 minus 5. So I have 3/9 minus 2/3. Let's make them all over 3. So my last one will be 15 over 3. This would cancel to be 1/3. So 1/3 minus 2/3 minus 15 over 3. 1/3 minus 2/3 is negative 1/3. So this will be negative 16/3, which is going to be negative 5 1/3. And we can see on the graph here, I'll zoom in, this is negative 5 here. And negative 5, it's less than negative half. So yeah, negative 5 1/3. Great. All right, let's try another example. 4x squared minus 35x plus 24. I first check to see, can I use my GCF method? I'm going to run down this list in order. There is no GCF other than one of 4, 35, and 24, so womp womp. Then I look for the AM. First thing to note, is it equal to f of x, y, or 0? It is. Okay. Is my first quadratic term 1? It is not. So I can't use AM either. So I'm going to try grouping. My first step in grouping is to make my guide on the side 4 times 24. 4 times 24 is going to give me 96, which is pretty big to find factor pairs. So what I can do is use a calculator if I feel the need. 1 times 96, obvious. Then I'll do 96 divided by 2, which is 48. Then I could do 96 divided by 3, which is 32. And then I can start using halving and doubling, which we've talked about a lot. I can double the 2 to get 4, cut the 48 in half to get 24. Okay. I could double the 3 to get 6, cut the 32 in half to get 16. All right. I could, 5 doesn't go in because it ends in a 6, so it's okay to skip it. 7 doesn't go in. 8 would go in because I could double the 4 to get 8 and cut the 24 in half to get 12. 9, I don't think 9 goes in. No, it's not part of the 9 times tables. 10 doesn't go in, 11 doesn't go in, and then I'm back to 12. So what I have right now are all the factor pairs of 96 that are integer values, which is what I care about. And I'm looking for one that will give me negative 35 with a positive 96 product. Positive 96 product means they have to have the same sign. So if one negative, one positive, not going to work. So let's have a look over here. I think it's going to be 3 and 32. If I look at 4 and 24, that's 28 or 20. No, 6 and 16 is 22. 8 and 12 is 20. 2 and 48 is 46. So it's got to be 3 and 32. Now, if I use positive 3 and positive 32, that adds to positive 35, but I need negative. So I'm going to use negative 3 and negative 32. I'll split this up. 4x squared minus 3x minus 32x plus 24. I split it down the middle. On the left side, I factor out x, so I have 4x minus 3. On the right side, I also have to have 4x minus 3. So what I factor out of negative 32 to get positive 4 and positive 24 to get negative 3, I would factor out a negative 8. Now I know this is equal to 0 because I'm trying to find my x-intercepts. I collect my pieces. So 0 is equal to x minus 8 and 4x minus 3. I can use my zero product property. 0 equals x minus 8, so 8 is equal to x. Or 0 is equal to 4x minus 3, 3 is equal to 4x, and 3/4 is equal to x. So those are my two roots. We can double check that. There's multiple ways to do that. One is to substitute these values of x. The other is to try a different method, maybe quadratic formula, maybe even make a graph, but I'm pretty sure we'll find the same results. Now we could find axis of symmetry using x equals negative b over 2a. That's usually the easiest way to find the axis. Again, I could find the average of these two. I don't know, about 8 3/4 divided by 2. Maybe I don't want to do that division, but I also want to know, and confidently I can use this formula here, negative b over 2a. So negative 35 over 2 times 4. So I have positive 35 over 8. 35 does not divide by 8 evenly, so I am going to get 4 and 3/8, which makes sense to me, right? If I wanted to find the average of these two numbers, I would have 8 3/4, and then I divide it by 2. Well, 8 divided by 2 is 4, and 3/4 divided by 2 is 3/8, so I get the same thing. Isn't math amazing? I love math. All right, axis symmetry vertex, we just talked about that. Let's move on from that. Solve for the roots of the following. First thing we need is to make it equal to f of x, and then ultimately 0, so I'm just going to write 0. I'm going to do this one without narration. You can follow along, pause, whatever you think is best for you. All right, so here I find that my two roots are positive 3 and negative 9 over 2, which is negative 4.5. We could double check this by substituting in. I invite you to pause the video, give that a try, but these are our two roots for our quadratic. There we go. So that's the grouping method. We have at least one more example of this. If we wanted to find the axis of symmetry or vertex, we could use x equals negative b over 2a. Remember, we can use the original or the factored version for the axis, but the vertex you are going to substitute into the original once you get that x value. So a is equal to 6, b is equal to 9, and c is equal to negative 81. So this is equal to negative 9 over 2 times 6, so negative 9 over 12. 9 divided by 12 is going to be 3/4, negative 3/4. When you simplify it, so negative 0.75 if you like decimals, which I certainly do not, negative 3/4. And we can see on our graph, it's counting by ones, and our lowest point is a little bit shy of negative 1, so negative 3/4 makes sense to me. So our axis of symmetry will be there. Now if I wanted to find my vertex, I would substitute that back into the quadratic. I will not demonstrate that. Feel free to do that on your own. We take negative 3 over 4, substitute it into this original, again, the original, and that's going to give us a value. It looks like the value is negative 80 and change, maybe like 80 and 7/8. You can let me know what that is, maybe in a comment. Wouldn't that be fun? All right, solve for the roots of this. Again, I will do this without narration. You can follow along as you wish. First thing I want to point out, there is no GCF. So I am going to have to do this with 6 times 25. Well, hold on one second. There is a GCF of negative 1. I definitely want to pull that out. But no GCF is going to change our values, just our signs. So go ahead, pause the video if you feel that's necessary, and then you can watch as I do it as well. All right, so those are our two roots. A lot of writing involved in this example, but again, our first step was to factor out -1. We really don't want to use grouping with a negative value in our quadratic term. We can, but it's just so much easier not to. So we factor that out. If we're going to make a quick sketch of this, we're going to know that our two roots are both negative, -5/2 and -5/3, but we are going to have to remember that our original was frowning. If this opens down, it's going to look something like this, and then we can find our other values from there. I invite you to do that. Pause the video, give it a try. For the purpose of keeping the video under 6 hours long, I am going to move on to the next example. Feel free to pause the video here, give this a try as well. All right, so there are two roots. N is equal to 2/3, n is equal to -3/2. And of course, n and these other variables, we could use whatever letter we like. These are representing our inputs, so these will be x-intercepts when we graph them on our xy coordinate plane. You could always change the letters on the coordinate plane, but typically they are x and y, so these are our inputs along the horizontal x-axis. If we wanted to find a y-intercept, we would go back to our original quadratic of -6 being our value of c. Even if we factor out a GCF in the last example, we did factor out a GCF, but the y-intercept would be from the very, very, very original quadratic we were given. All right, we have one more example here. Give it a try, pause the video, see how well you do. Hopefully at this point, you're doing great with these examples. I'm gonna do this without narration, and we can see what we get. So those are our two roots. B is equal to 5/4, B is equal to -5. Our y-intercept is going to be -100. Our axis of symmetry, we can calculate -b/2a, -60/2 times 16. So we get -60/32. 60 does not divide evenly by 32, but we do get negative 1 7/8. And that's going to be our axis of symmetry. You can go and find the vertex. You can find all sorts of other things. But remember, this graph is going to be a smile. The a value is positive. And it's going to be pretty tall and skinny because the a value is positive 16. So it's going to be very skinny. We can see here a y-intercept of -100 indicates that this goes really far in each direction. So that's the end of factoring by grouping. Hopefully this was helpful. Our next method will be completing the square, and that will be our next video.